This is a great question. We're asked to find all the ways in which 200 can be written in this form where P, Q, and R are prime numbers. So I'm going to start by writing down my first few prime numbers, 2, 3, 5, and so on. Then I'm going to square them. 4, 9, 25, 49. Now 14 squared is 196, so 17 squared is definitely going to be bigger than 200, and there's no way we could get that as a solution. So yeah, q squared is going to have to be less than 17 squared. And if we take a look at the cubes, we're going to have to look at even less. 8, 27, 125, but 7 times 49 is going to be bigger than 200 for sure, so I can ignore all of these as well. Let's work through this systematically by considering these three cases one at a time. So first of all, r equals 5 will give r cubed equals to 125, and therefore p plus q squared will equal 75. Now we have a whole number plus another whole number equaling an odd number. So 1 of p and q must be even, and the other must be odd. This is particularly useful because we're dealing with prime numbers, and there's only this pair that we could possibly have in our list. So first up, we could have that p is equal to 2, which implies q squared will equal 73, but this is not a square number, so this is not a solution. And that leaves q equal to 2, which implies that p will be 75 minus 4, 71. So this is okay. 71, 2, and 5 is a first solution. Next up, let's take a look at r equaling 3. Then r cubed is going to be 27, and p plus q squared will equal 173. We're going to get the same scenario again. One of p and q must be even, the other odd. So again, let's go with p equal to 2. Then q squared will now be 171, again, not a square number. Q equaling 2 will give p equal to 169, but this is 13 squared, so not prime. So no solutions for r equaling 3. Finally, we have r equaling 2. Just going to bring my list of primes and squares down to help. So then r cubed will equal 8, and p plus q squared will equal 192. So now both p and q even or both odd. And I can work backwards, I think, from here. So q squared equaling 169 will imply that p is equal to, what do I have to add on? it would be 13. No, sorry, 23. So that's okay. Therefore, another possible solution is going to be 23, 13. Remember, it's 13 squared, and then 2. Let me just check. Yeah, P, Q, and R. That's the form I'm writing it in. So next up, let's go with 121. This gives P equal to 71, and that's okay as well. 71, 11, and 2. Q squared equals 49. Implies P. So 192 minus 50 is 142, so it's going to be 143. This is a bit of a sneaky one, but it's actually 11 times 13, so it's not going to give us an answer. It's not a prime number. 25 gives P as 167, and this is okay. So 167, 5, because that's 5 squared, and 2. Q squared is 9. Implies P will be 183. The sum of the digits is actually divisible by 3, so this is necessarily divisible by 3. It's in fact 3 times 61, so that's not an answer. And finally, we got Q squared is 4, but remember, the only way we would get an answer here would be if P was then the only other even number, which isn't going to add up to 200, so we can reject it. So those are our 4 solutions: 71, 2, 5, 23, 13, 2, 71, 11, 2, 167, 5, 2. We've worked systematically and shown they're the only ones. Well done.